Just Energy with naturopath and medical intuitive Dr. Rita Louise. We have learned from Einstein's theories that matter and energy are one. Physicists believe that all systems in nature have their own particular way of vibrating. From the swing of a pendulum to the waves in the ocean to the light that brightens the sky each day, each of these oscillates at its own unique rate. In the same way, things such as rocks and minerals vibrate very slowly and at speeds that are imperceptible to us. Living things such as plants, animals, and man vibrate faster and appear to be alive. The same holds true for every thought, feeling, event, or word we speak. Each has its own frequency or rate of vibration. What many of us don't realize is if we take everything in our own universe down to its simplest form, it is all just energy. Join Dr. Rita as she explores questions such as, what are we made of? Why do we get sick? How can I live a more balanced and whole life? Call in and talk to her and her thought-provoking guests. Send us your questions and get the help you need to move beyond any obstacle or challenges that may be affecting your life, right from the source. So stay tuned and explore your possibilities.
Hello and welcome to Just Energy Radio. I'm your host, Dr. Rita Louise, and thank you all for tuning into the show today. Well, I guess if you're listening to the show, you didn't get raptured last weekend, which I guess could be a blessing and a curse. But I'm glad that you could tune in because we're going to have a fabulous show. In the first hour, we're going to be speaking to Walter Cruttenden about human evolution and the precession of the Equinox, and much more. And in the second hour, we're going to be speaking to Susan Martinez about the quickening. But don't forget, Just Energy Radio is brought to you by SoulHealer.com and the Institute of Applied Energetics, where you, too, can learn to become a medical intuitive counselor or certified energy medicine practitioner. You can get more information about that at www.appliedenergeticsinstitute.com. Just Energy Radio is also broadcast live on the Fate Radio Network. So to keep informed of what's going on Just Energy Radio and sign up for our weekly newsletter, go to www.justenergyradio.com. And remember, you can always check out our over 4 years worth of archives that has excellent programming like you're going to be hearing today. Well, I have a ton to talk to Walter about, so let me introduce him and get him on the line because, you know, I get books from the authors and, you know, have the schedule set up and go, God, I should have, set up 2 hours with this guy because I already can tell we're not going to have enough time. Anyway, Walter Cruttenden is the director of the Binary Research Institute in Newport Beach, California, author of Lost Star of Myth and Time, and writer-producer of the award-winning documentary film The Great Year, as well as many articles and papers on the subject of solar system motion and its influence on history and consciousness. Walter is the host of a regular podcast series, The Cosmic Influence, and organizer of the annual conference on Precession and Ancient Knowledge, CPAK, which features authors and scientists from around the world addressing the topic of ancient knowledge. So please welcome to Just Energy Radio, Walter Cruttenden. Hey, Walter, thanks for coming on the show today.
It is my pleasure, Rita.
Let me ask a question here before we get into our whole topic. Your conference that you have, the Conference on Precession and Ancient Knowledge, CPAK, what's that all about, and when does that happen? I've heard about it kind of through the grapevine, but I'm not really familiar with it, and I'm sure the listeners would be interested in getting some more information about it.
Well, each fall we pull together a bunch of authors and scientists, researchers that are looking at this general idea that ancient cultures knew a lot more than we did in some areas, and that there might be a cycle of time that the ancients spoke about, this rise and fall of civilization. And so I talk about some of the solar system anomalies that suggest solar system motion might be a cause of the cycle, but others, such as Robert Schoch and Graham Hancock, will talk about some of the ancient structures that you'd find in other parts of the world that suggest that civilization is older than we thought it was, and still others, we have physicists and doctors and things might speak to, what the leading edge of science today is doing and how that might explain some myth and folklore, say, about telepathy or clairvoyance or something like this. So it's a real fun time, and we hold it usually at a different university, but this year it's going to be held in Sedona, Arizona at the Hilton Hotel, and it should be a blast.
When is it scheduled for?
Let's see. This year is September 30th to October 2nd. And if any of your listeners are interested, they can go to www.cpakonline.com. That's CPAK online.com.
Excellent. Personally, I think the ancients knew a whole lot more than I think we know, and we're just rediscovering what they knew thousands and thousands of years ago.
It's true, and when I was a kid, they said that civilization is about 5,000 years old, and before that, we were hunter-gatherers. And then, of course, they kept finding things that were older than that, and then finding evidence of, advanced, say, knowledge of astronomy, mathematics in Babylon, or, advanced engineering systems, ziggurats, pyramids, even these underwater sewer systems that they found throughout much of the Mideast, or in Mohenjo-Daro and Harappa and in the Indus Valley, they found that they're building with uniform bricks, and they have indoor plumbing and heating. And this is a culture that's probably 5,000 or 6,000 years ago. You think about when indoor plumbing and heating came to the West. It was really just a few hundred years ago. And so, our view of ancient cultures, pre-Dark Age cultures, has kind of gone from that they must just be a very primitive people to, hey, there's something really going on here that we should pay attention to.
Yeah, I think there are some incongruencies when you look at the knowledge that they have and then say, oh, but they were living in caves and using sticks. It's not congruent, in my opinion.
No, it's not. And part of it is because we have this linear paradigm that pretty much says, if it came before us, it must be more primitive. And the ancients talked about this vast cycle of time with alternating dark and golden ages that Plato called the Great Year. But we're taught, that that's just a fairy tale, that there is no cycle, there was no long-lost golden age, even though archaeologists, historians, anthropologists do acknowledge a recent dark age. And so, that's our whole area of research, is trying to figure out, was there really a golden age? And the evidence is pointing more and more towards that. And if so, how does it work? What drives it? What was it like? Where are we now if there is a cycle? And all that sort of thing. And so the main focus here at the Binary Research Institute is looking at the celestial motions that may have a cyclical impact there.
And there are a lot of people that associate that cyclical nature of our universe to the precession of the equinox. Now, I'm familiar with that concept, but I'm not sure if all my listeners are. And I was wondering if we could kind of start there and lay some groundwork as far as what the precession of the equinox is, and then kind of build on from there.
Gladly. Well, precession is, according to Copernicus, it's the third motion of the Earth. And I think everybody knows the first two. The first one is the Earth spins on its axis. This is the diurnal motion. And, in Copernicus's time, before his time especially, they thought that, well, that's because the stars and planets actually move around us and that the Earth didn't move at all, the old geocentric system. And, of course, Copernicus explained, no, the Earth is spinning, and that's why we see the stars and sun rise in the east and set in the west. And the second motion is the Earth's revolution or orbit around the sun. And again, that causes us to see a different constellation overhead each month. And so we see about 30 degrees different portion of sky every month, so that in 12 months, we've seen 360 degrees worth of stars. And Copernicus explained that that's because the Earth is orbiting the sun. And that was easy to understand. And there is a cycle tied to each of those. In the first one, the cycle of day and night is pretty obvious. Our consciousness actually moves from a waking state, where we are right now, to, a sleeping state when the sun goes on the other side of the Earth, simply because our bodies have adapted that way. We actually go into a subconscious state, and people don't think anything about this fact that our consciousness changes with the motion of the Earth. And likewise, the second motion, Rita, is producing just as big a change. Plants spring out of the ground, bloom, give their fruit, decay again, and billions of other life forms are, coming out of hibernation or spawning or migrating in mass. And it's all because of a celestial motion. All this life on Earth is moving in sync with these basic motions. And so there is a third motion that Copernicus was aware of, called the Precession and Equinox, because ancient astronomers had talked about it. And it's very, very subtle. In this one, the stars don't move from the east to the west. They move the opposite direction. It's called retrograde. And they only move about 1 degree per 72 years, meaning that it takes about 25,000 years to completely go retrograde one cycle, one great year. And this one, scientists acknowledge that it's real. You can actually see the stars move, and they observe the amount of change. It was about 50.3 arc seconds last year. But Copernicus and Newton and others said that this is simply due to a wobbling of the Earth, and therefore, even though all the ancient cultures, not all, but at least 30 of them, talked about a cycle related to this motion, that they don't recognize any cycle related to this third motion. And part of the reason for that, Rita, is that it was just thought to be a wobbling of the Earth, and therefore there's not much going on. It couldn't cause a big cycle like the diurnal motion or the Earth's orbit. And the reason Copernicus thought it was just a wobbling of the Earth was because he had just established that the sun is the center of the universe, and everything goes around the sun. And the last thing he could have added onto his theory at the time was, oh, and by the way, the sun also moves. He was thought to be crazy anyway by most in the church. And so for him to say that the sun moved, and that's why we see the sun moving through different constellations of the zodiac, say, over long periods of time, just wouldn't have made sense. And so this theory that this precession equinox is just related to the wobbling of the Earth has grown up for a few hundred years, but all our research shows that it's not simply due to the Earth wobbling. It is mostly due to the sun actually moving through space, which astronomers are starting to recognize that, yes, indeed, the sun does move through space, and this does slightly change the Earth's orientation relative to the stars. In other words, it affects the degree of precession. And so what we're arguing about right now is how much it affects it. And it's a fun conversation. That's where we kind of get technical, but the point is here that the precession is the third motion of the Earth, if you will, and it's actually caused by the whole solar system moving, which we believe results in a great cycle every bit as profound as the first two cycles.
Okay, that's a different definition than what I've heard. I was led to believe it's because of the tilt of the planet and it making that revolution on the axis over time. We're not talking about the same thing. I mean, it doesn't sound like we're talking about the same thing at all.
Yeah, the axis is tilted by 23.5 degrees, 23.4 degrees roughly. And the precession really doesn't change that tilt. But we do see it does cause the stars to move retrograde, or it does cause us to see the sun moving through different constellations of the zodiac, And yes, a lot of people still, I'd say that's the mainstream science right now, is that, it must be due to the gravitation of the sun and the moon acting upon the oblate Earth and wobbling it a little bit. And we really, really study this with astrophysicists, mathematicians, and lots of models, and we find that, yes, there is something called nutation. When the moon goes below the Earth's equator for about 9 years, the Earth will tilt a little bit towards that direction, and when the moon goes above the equator for about 9 years, the Earth will tilt in that direction a little bit. But that is all that we believe these local gravitational forces are causing. The precession movement itself cannot be explained with just those local gravitational forces. That's where you need the solar system in motion.
You mentioned 26,000 years, and it always blows my mind. See, this is one of those incongruencies that mainstream science throws out there. The story I've heard when the question has been posed, how did ancients figure that that there was something going on if it's only moving 1 degree every 72 years, which with the naked eye, even if you're using some kind of fixed pointing device, I don't really know what they would use back then, but some kind of device to measure, 1 degree would be so insignificant that there would be no way in any one person's lifetime to have any kind of noticeable movement. How do you think the ancients figured this out?
That's a good question, and you're right. It is very difficult to see if it's only moving 1 degree in a lifetime. Most people would think, well, maybe I just didn't see it clearly the first time. But, people have written down the position of the stars, and it was the first Westerner to really recognize precession. It was the Greek Hipparchus, and I think it was about the year between 100 and 150 BC, somewhere right in there. And apparently he was going from records that had been written down several hundred years earlier. And so he noticed it, and he plotted, I think according to his calculations, it took about 36,000 years to make a cycle. But, of course, since that time, especially after the Dark Age, astronomers really zeroed in and got this thing down, and they know that it's now moving at the rate of, about 25,700 years at the current precession rate. That's how long it would take to make one cycle. And I don't know exactly how the ancients did it, to answer your question, but they certainly had structures that were just, big, heavy stone structures, be it Avebury or Stonehenge or things like this, where, if a person stood and set their eye right on a crease in the rock or something and looked over a distant stone, they could notice very small amounts of change over a couple of lifetimes or so.
So basically it's still a mystery, which is okay.
Yeah, it's still a mystery, as so much of these ancient cultures is. You know, you think just so much of that we've been taught is we're slowly making discoveries to overturn that. And let me just throw out a couple. Geared devices. This is something that we were taught, you know, these were invented during the great clockmaking era, roughly 12, 13, 1400 AD. And before that, gears didn't exist. And then, of course, they found this tremendous find in this Greek shipwreck that's unquestionably dated to at least 100 BC of this thing they call the Antikythera device, because it was found off the Isle of Antikythera in the Aegean Sea. And it has 32 precision gears, you know, very fine tolerances, and it's used to plot the positions of the planets. It's like a computer. So they had very sophisticated gear mechanisms long before they were invented, you know, post-Dark Age, if you will. Or batteries. You know, batteries were invented by Volta in roughly the year 1700. And that's what we thought until the Babylon battery was thought. And these are at least 2,000 years earlier. And although they're also crude batteries, they have twice the voltage that Volta's early batteries had. And you can go on and on, you know, dentistry, orthodontics. Dentistry, you here in California where I am, or, you know, anywhere in the U.S., a couple hundred years ago, if you had a bad tooth, you'd go to the barber shop, they'd give you some whiskey, and they'd yank it out. They've found skulls in Pakistan that are 8,000 years old, and they have neatly drilled rear molars. And they've taken them to dentists, and they, without the dentist knowing the age, they say, you know, tell us about this. And the dentists say, hey, that's very good work. You can see there's different size drills used. Whoever did this is pretty good because he drilled here close to the enamel and didn't break it off. You know, no crown is required. And they can't believe it when they're told that it's 8,000 years old. So there's things like this all the time. You know, even the heliocentric system, which we just talked about, that Copernicus, you know, developed in 1483. It was found that there were 5 books in Copernicus's possession. 2 of them were ancient Greek books. One of those talked about the heliocentric system. It was Aristarchus of Samos, roughly 2,000 years before Copernicus, in the year roughly 500 BC. And so we have all these things that were around and lost during the Dark Ages, and then sort of rediscovered when we had the Renaissance, which means rebirth of the cycle.
With these cycles, do they have, I mean, we're talking about the movement of the planet and the cycles of the planet. Does the movement of the planet have an impact on us and our consciousness? It sounds kind of like it might, from what I'm hearing you say.
Yes, it does, but I wouldn't say so much it's because of the movement of the planet. It's because of the change in light that is caused by the movement of the planet. So, you know, if you just look at the rotation, the diurnal motion, when we go towards the light, we're in the sunshine, things happen. Photosynthesis occurs. Lots of life is very active. And when we turn away from the sun, things obviously don't grow so well, and life, you know, moves into just a much slower pace. And same thing with the orbital motion, although, you know, sort of on a different scale, if you will. And so, yes, you can say that planetary movements affect us, but it's probably more accurate to say that the waxing and waning of those celestial motions in relation to a star, in this case our sun, you know, is the closest star, and it has a huge electromagnetic spectrum that's made of everything from infrared to ultraviolet. There's, you know, gamma rays in there, X-rays, you name it, is in this spectrum that we see, of light that we see, and we actually only see a very small portion of visible light. And so there's things in there that we need, and as science grows, we're learning more about that. You know, for example, there's a disease called SAD, seasonal affective disorder, where some people are just more than bummed when it's not a sunny day. They're actually have depression, and it causes real problems in their life, and that's treated with light. Or jaundice, babies. You know, that can be a very serious disease, and it's simply treated with ultraviolet light. And so light has a big effect on us, and when we are away from the light, we operate one way, and we're moving towards the light, we operate the other way, in a different way. And so sort of the hypothesis, then, you will, for how this rising and the falling ages might occur, and I say might because, you know, this is all hypothetical stuff right now, but we do believe, since so many ancient cultures talked about it, that it has a basis in reality, and that's why we're trying to figure it out, is that as our solar system moves closer to and farther away from another star, and this might indeed cause us, you know, to drive us closer to and farther from even another point in space, that it's having some effect on us, just like the diurnal or orbital motion would have on us, except this latter effect that takes place during the precession of the equinox, which we would say, you know, one orbit of our solar system around another star, is obviously on a much longer time scale than the daily or yearly motion. And if I can, I like to give the example of the mayfly, because that's sort of what we're like. You know, the mayfly is this insect that lives just one day a year. And Rita, if it happens to be born on an overcast, windless day, you know, it knows nothing of sunshine. It knows nothing of the ease of riding a breeze. It just, that's its perception of what all history is like. And so we too, our lifetimes are the equivalent of, you know, 1/360th or so of a great year. And so we're like the mayfly. We just live for a fraction of this whole cycle. And so we say, well, life doesn't really change much. You know, maybe things were a little more primitive when we were born, and they're a little bit more modern when we die, but we don't see any big changes, you know. And yet there's changes going on all about us, and if we could just have that perspective of looking, you know, many lifetimes, or what things were like in higher or lower ages, we'd see that they're dramatically different than they are right now.
Walter, why don't we go a little bit early to our first break and come back and talk about the different ages, because I want to also talk about the lost star. And as I said when we first came on, not enough time. Hey, I'm Dr. Rita Louise. We're talking to Walter Cruttenden about his book, Lost Star of Myth and Time. His webpage is loststarbook.com, and we'll be back after these words from our sponsors.
Just Energy Radio with your host, Dr. Rita Louise, will return right after these messages. And now back to Just Energy Radio with Dr. Rita Louise.
Hello and welcome back to Just Energy Radio. I'm Dr. Rita Louise, and we're here talking to Walter Cruttenden. His book is Lost Star. His website is Lost Star Book. Walter, before the break, we were just starting to touch on the different cycles of time, and you mentioned earlier a golden age, and you've also referred to the dark ages, which we're all familiar with historically, or hopefully we're all familiar with historically. When was this golden age, and is there more than just two ages?
Well, yes, the Greeks broke it down into the Iron, Bronze, Silver, and Golden Age, and that corresponds, Rita, with the Indian teaching of these cycles, which they called the Kali, which would be the Iron, then the Dwapara, the Treta, and the Satya Yuga, which would be their Golden Age. And they're both the same periods of time. It's roughly 24,000 years for a whole cycle. So to ascend through the four ages takes 12,000 years, and then to descend through the four ages takes another 12,000 years. And this is one precession of the equinox. And it's actually, we believe, where our current system of time came from. We can trace our system, which has 24 hours, 12 hours of AM, where we go to the zenith of light at 12 noon, and then 12 hours of PM, where we go away from the light. We can trace that to ancient Egypt, ancient Mesopotamia, but beyond that, we really don't know where it came from. And it appears that it's an exact microcosm of this great year, if you will, and all this time we've been wearing it on our wristwatches. But yeah, the four ages are really interesting, and to try to understand them a little bit better, you can look to, say, the work of Giorgio de Santillana. He was the former professor of the history of science at MIT, and he wrote a book with another brilliant scholar, Hertha von Deschen, called Hamlet's Mill. And this book looks at the myth and folklore of over 40 ancient cultures, and most of them spoke of this vast cycle of time encompassing alternate dark and golden ages, which they associated with the movement of the heavens. So they didn't always call it the precession of the equinox, but they called it, the movement of the heavens, or a yuga cycle, or a great year, depending on which culture. And then some of these cultures gave us some details, but it's funny, Rita, when we hear these cultures talk about the Dark Age, we really don't doubt it too much, because that's fairly recent. Heck, just 500 years ago, every nation was at war with each other. Plagues ravaged the earth. Lifetimes were about half what they are now, and we don't doubt that. And yet when they speak of the Golden Age, when Hesiod says, long ago the mankind lived in tune with the earth gave of itself freely, we lived in a time of peace and plenty. It's even insinuated in Genesis in the pre-Babel age that mankind spoke with one tongue, that you could commune with nature almost telepathically or clairvoyantly. And that, of course, we all consider to be myth and folklore. And so I think it's because where we are now, we just can't imagine that things are that much different, other than worse. And part of this is because of the cycle itself, I believe. There's a great scholar. He won the Leibniz Prize. He's the foremost Assyrianologist in the world, Stephen Mall, and he spoke at the Stanford presidential lectures there. And he reads these cuneiform tablets probably better than anybody. And he found out some very curious things that the ancient Mesopotamians, the Akkadians, were talking about. And he said that roughly 3,000 to 4,000 years ago, they were practicing archaeology. And when they came across a building that was 3,000 years old in their time, so that's 6,000 to 7,000 years for us, they would try to put it back together without, quote, deviating more than an eyelash, unquote. And so they recognized that there was something significant to these very ancient structures, and they didn't want to change them too much. And they talked about this cycle. And they knew that the Golden Age was behind them, and they were going into a darker age. And sure enough, they were absolutely right. I mean, they went from a great culture that knew mathematics, astronomy, built ziggurats, Hanging Gardens of Babylon, tremendous engineering capabilities, to a nomadic tribe civilization. Same thing happened in Egypt, same thing happened in Indus Valley, and pretty much everywhere in the world you look. Things went backwards. Another thing that Stefan Moll found was he's an etymologist, linguist, so he can follow the meaning of these symbols, these words through time. And he said there's something amazing that's happened, and that is that the Akkadian word, the ancient Akkadian word for past, has become our word for future, and their word for future has become our word for past. And if you understand the cycle, this makes sense. So for them, the Dark Ages was in front of them. They didn't want to really go forward in time. They wanted to go back to the Golden Age. They feared the future, and it turns out for good reason. Whereas for us, we wouldn't want to go back 500 years, 1,000 years. The Dark Ages were very dark and miserable time. Zero human rights, zero health care, zero democracy. And we want to go forward because the Golden Age is ahead of us. So sort of subconsciously and in our language, we orient ourselves in time to where the Golden Age is, if you will.
Walter, I don't mean to totally change gears here, but we have 20 minutes left, and we need to go here. In your book, you contend that our sun is not alone, but it's actually part of a binary system. Is that based on current science, mythology, both?
Both, but mostly modern science. So we had heard about this ancient myth, and for example, the Shinto talk about a second sun. The Egyptians seem to make reference to it, and so what we did was we tested a moving solar system model versus just a single sun model to see if a binary system, which is simply, our sun in a gravitational relationship with another star, which, by the way, most stars are. 60% of sun-like stars in our local neighborhood have partners. And recently we've been discovering more and more brown dwarfs, and so NASA estimates that it might be 80% of all stars are in multiple star relationships, mostly binary, but some trinary or even more than that. And so, if this is true that our sun has a partner, then you would expect it to be detectable through different sorts of means and mechanisms. And so we did a lot of research. And so if precession, the stars moving retrograde across the sky, is due to our sun's motion around another star roughly every 24,000 years, as the ancients taught, then the precession rate should be speeding up because it's running a little slower than that right now. And so we built a model using Kepler's laws and the data given by this moving solar system model, if you will, and we compared that to how the current way of predicting the precession rate. And I don't want to get too technical here, but the current method says the precession rate, would increase at 0.222 arc seconds per year. And this is according to the greatest astronomer in the West, Simon Newcomb. And we matched that against this moving solar system model, and we thought, no, over the last 100 years, the precession rate should have gone closer to 0.349 increase. And sure enough, the actual rate is 0.346. So if you will, the ancient models are actually more accurate when you use modern scientific means to model them. And we found that it answers a whole bunch of problems for, anomalous acceleration of the Pioneer satellites, some IBEX data that we're getting from some of the spacecraft that are out there, and there's all sorts of indications that indeed our sun does seem to be moving through space, and there probably is a partner to our star out there. And let me give you just one last little piece of potential evidence on this topic. There's a very brilliant astronomer at Caltech right now. His name is Mike Brown. He has found more Kuiper Belt objects than anybody. These are these big, massive objects past Pluto. And in fact, he's considered the guy that killed Pluto because he found a planet that's bigger than Pluto. And he's found a planet called Sedna, which moves in resonance with this 24,000-year orbit. It's actually a 12,000-year orbit, so it's 2-to-1 resonance, which is exactly what you would expect if we are in a binary system. And Mike's come out and said, Sedna can't have this orbit with what we know about our current solar system. There has to be either a big 10th planet or another star out there or something big. Sedna just does not have this elongated orbit for no reason. And so he and others like Whitmire and Matisse at the University of Louisiana and Richard Muller at UC Berkeley and others are now getting serious about looking for a companion for our sun. And that's about where the status of the science is right now.
And I'll just say recently. We'll just say recently. There has been a lot of clamor on the internet about them having found a brown dwarf, in our local galaxy area, neighborhood. I guess it wouldn't be in our galaxy. In our local universal neighborhood. Is this what we're talking about? When I was reading the information, I'll just put it this way. When I was reading the information, certain people were saying, oh, yeah, there's this brown dwarf, and then other people were saying, well, there's theories that there's this brown dwarf there, but it didn't seem particularly conclusive in either direction. But are we actually talking about the same piece of information?
Yeah, and I think you've actually done a very good job of describing it, because we know that there are brown dwarfs in the galaxy. Heck, there's billions of them in the galaxies. And we know that there's some brown dwarfs in our stellar neighborhood. And there's some who say that there might be a brown dwarf as a companion to our sun, because these are very difficult to see stars. And particularly if it was towards the galactic center or, where there's so much light radiation in the background that it would make it difficult to detect. But there's nothing confirmed yet. Nobody for certain has, this is not a mainstream view that we've found a brown dwarf. There's some that say they have hints of it, but no, it's not there yet. And that's just one possible candidate for a companion, A red dwarf towards the galactic center would also be very difficult to see. There's theoretically some planet-like masses, even cooler stars that are out there. Of course, there's black holes that exist, and I'm not saying there's one close by, but they're very difficult to detect unless they're consuming matter. And I had a meeting with some people at Stanford, and they've got some funny data, and they think that it's possible that there might be one not too far from our neighborhood here. And so there are people looking, and there's even some that, and you can put me in this latter camp, that think it might actually be a visible star, and that the solar system is moving faster than we think it is. And so I kind of go to that camp.
Okay. There are people that, you find all kinds of stuff on the internet, true, false, but it's all true because it has to be, because it's on the internet, that are associating, brown dwarf equals planet X equals Niberu. Any comment on that at all? I mean, obviously you're saying that there isn't any hard, fast information that a brown dwarf truly exists and we're in this binary relationship. But
right, I don't personally. I don't think it's a brown dwarf. Niberu is, it's got a sort of a bad rap lately. But if you look at the early texts on it, this is Mesopotamian writings, and the best source there is, again, Giorgio di Santillana, this brilliant former professor of the history of science at MIT, and he talks about it in the back of his book, Hamlet's Mill, and it means brightest object in the sky or brightest star. And so, to me, that's the star Sirius, and to others, we actually think it's the star Sirius. It's not only the brightest star and very close to us, but it's the heaviest thing in local space. So if you think of, this Einstein vision of space where it's sort of like a rubber platform, and the heavy objects cause other objects to orbit around them because they make a dent in space-time. Sirius, with its own little companion, white dwarf that goes around it, that's super dense, would be the heaviest thing in local space. And also the Shinto, they call Sirius our second sun, and they align their temples to it. To the ancient Egyptians, Sirius was their most revered star. It was Isis, and Isis would bring life and then take it away. And you often see Isis in a relationship with Horus, which is an aspect of the sun, much as you would expect if there is a gravitational relationship between Sirius and our own sun to be. And there is a lot of evidence there, the homins out of Canada, and a lot of historical evidence, some great scientists that have noticed that Sirius acts a little bit differently. It doesn't seem to precess like the other stars do. And one that recently mentioned this is Jed Buchwald. He's an astronomer at Caltech. And so that's kind of where I lean toward this, that Nibiru actually means Sirius, and Sirius is a very logical candidate for a gravitational partner if our solar system is moving fast enough.
There's a huge difference in space, between where they're postulating this brown dwarf is and where I'm not a astronomer, and where I would assume Sirius was.
Yeah.
I guess it just kind of boggles my mind that we could have some kind of a, gravitational relationship with a planet that I would make the assumption is that far away.
Yeah, I think you're stating the obvious very well, that people think if it's a brown dwarf, it can be much closer, and it's easier to make the case because our solar system doesn't have to go very, very fast. And but there is a scientist, so we figured to get around Sirius and have a roughly 24,000-year pattern, you need to get around a center of mass that's about a little over 6 light years away, because you don't have to go all the way to Sirius. You know how binary systems work. Both stars move around the center of mass between the two. We'd have to be going roughly 430 kilometers a second, if there's no other physics going on that we don't know about. And there is an astronomer, an astrophysicist out of Australia, Reg Cahill, that has made that very assertion. He's come out with that exact number. And it's difficult to measure the speed of the solar system because, it's relative to what? Everything else is moving, right? And so at first it was thought the solar system doesn't move at all in Copernicus's time, even Newton's time through about 100 years ago. And then it was realized, okay, the solar system does move, but it doesn't move very much, maybe 8 kilometers a second. And then I think the latest estimates are like 50 to 80 kilometers a second. And Reg estimates it has measured the speed relative to what we call the CMB, or the cosmic microwave background, sort of this static that's supposedly left over from the Big Bang. And he came up with exactly 430 kilometers a second. So I'm not saying that proves it, but I'm saying that is a very interesting coincidence that he comes up with the exact speed we need to get around a star like Sirius.
Walter, I'm going to ask a question that has absolutely nothing to do with your book, but I couldn't think of probably a better person to ask it. This is one of my own personal questions, and since you're very well versed in astronomy and mythology, I'm going to throw this one at you because it's kind of a mystery to me. One of the things that I have learned in investigating ancient mythology is that their calendars were based on a 360-day calendar plus 5 days. So if these people knew about the precession of the equinox and they knew about all of this stuff, why would they have a 360-day calendar? Well, let me just throw out my little theory, and then you can laugh at me if you need to, that perhaps somewhere back there our calendar was actually 360 days and something happened to the planet which added 5 days to the actual rotation, and so they had to add 5 days somewhere?
I think that's less likely than simply the fact that you want a fairly round number to be able to do a lot of math really easy. And since the Mesopotamians use a sexagesimal system, a 60-base system, that 360 just works out beautifully. And it was 360 plus the 5 days, which gets you very close. And we do know that they actually nailed the tropical year period and the sidereal year period. So they were very good at this. And also we know, based on all our studies, that it's highly unlikely that the speed of a planet is going to change much at all unless there's just some massive cataclysmic event. And I don't see any evidence of that in the time period that they were using a 360-day year. So, okay. There is one more point I'd like to make. I don't know how much time we have left.
We have about 2 more minutes. Okay.
But, so we're in this rising age. We're coming out of the dark ages, and sort of the wind is sort of at our back. It's like, we're in the very early dawn of a regular day, and things are getting sunny. It's easier to see. It's easier to work and get things done. Or we're in the springtime of a year when things are easier to grow. It's just easier to live as you move towards summer, et cetera. Same thing in the great year. We've just come out of the dark ages. We're sort of still in this renaissance, this tremendous age of discovery. And so the wind's at our back, but we're not entirely harnessed to this cycle. I mean, there are things that we can do to improve, to see better in the night, use flashlights, or to be warm during the winter. Likewise, there's things we can do to sort of raise our consciousness, meditation, eat better, things like this during the great year. We don't necessarily have to wait another 10,000 years for the golden age to make things better. And that's the point I wanted to make.
Cool. Thanks for coming on, Walter. As I said, totally not enough time. We'll have to have you back. Fascinating work.
Thanks, Rita. Yeah, we just barely scratched the surface, but love to be on again.
Your book, Lost Star, Myth and Time. Remind the listeners again about the conference that's coming up.
Yeah. Don't hear this cycle stuff just from me. Hear it from, a panel of a dozen experts who will be speaking over 3 days in Sedona, Arizona this fall. That's at the Conference of Precession and Ancient Knowledge called CPAK. And they can get information by going to cpakonline.com. That's CPAKonline.com.
Thanks, Walter. Well, you have a great Memorial Day weekend, and we will talk soon.
You do the same. You're sharp, Rita. Love being on your show. Take care.
Thanks. Cool. All right. Bye-bye. And that's Walter Cruttenden, and we are going to take a quick break. And actually, his webpage is loststarbook.com, and we will be back with Susan Martinez after these words from our sponsors.
Just Energy Radio with your host, Dr. Rita Louise, will return right after these messages.